Quantum computing is a whole new paradigm in computing. So you should think of quantum computers as machines that have not existed at all in the past. So don't think of a quantum computer as a beefed up classical computer. Think of it as a whole new paradigm for computing that can solve problems that existing computer technology will never ever be able to do.
Well, I'm a chemical engineer and a biochemical engineer, and of course my interests are within chemistry and biology and the industries associated with them. So in my view, biological industries, biomanufacturing, chemical industries, formulation industries, wherever we have this interaction of the molecules, and we have we need to scale them up, we need to build larger scale processes, and then we need to understand this whole complexity. That is where I see myself, that is where I see the application. That's closer to my heart.
Oh, there are many. It's like balancing a lot of stuff on a knife's edge. Maintaining coherence, maintaining entanglement are some of the basic challenges that we're facing in quantum computers, and we are battling a number of problems in trying to extend the coherence times and the quantum volume as we measure the performance of quantum computers, and to increase that gradually to a point where we can create a logical qubit, and from there a universal quantum computer. The research is in fields of noise, it's in fields of gate fidelity, in application. Algorithms are really hard to create. Give you an example. If you look at the most efficient classical sorting algorithm, the quicksort is invented in 1961. And apart from some few hybrid sort algorithms that have come to the field since, this is really the go-to algorithm for sorting. And analogously into the quantum field, creating new algorithms is really very, very tough. So we need as many people as we can get, smart people, to help us expand the toolbox, if you want, on the software side as well.
Well, I think that there will be a change in a way in the type of career of quantum engineers. At the moment, we still need a very specialized personnel. So we actually, the problem of quantum education, as it is known, or having a, in a way, workforce for all the startups and all the research endeavors is actually felt as one of the main difficulties of the quantum ecosystem. So we do need still very specialized PhD, at least PhD level researchers that know a lot about quantum physics and quantum computing, and also quantum chemistry is very interdisciplinary. But I think that as the time goes, it will become a bit different. I think that there will be more specialized figures that will not need necessarily a background knowledge of quantum physics to the extent that is needed now, but they will become more specialized in one application rather than the other. And also the quantum computers will become more like the classical computers. Nowadays, to use a computer, you don't need to understand the physics of the underlying devices. So we will go there, but we are not yet there.
Be prepared that it will be very stressful. Maybe also analyze yourself beforehand if you are a type of this kind of having such a management position. If you don't like to do presentations, if you don't like to be a bit in the spotlight, if you have never tried to set up a big project in the past, maybe try to figure out such kind of management positions. You can start with being in a student group and taking the lead in a student group. You can organize parties and just see how stressful that could be, and how you behave in when you organize a party with 200 people at the university. And if you figured out what kind of type of person you are, and you're really a curious, research-driven, and also have a kind of a business sense to things, and you're innovative, then I think you have the ingredients to start a company. Yeah.
I think quantum computing in the near term is going to be quite specific and will solve some very particular problems. And eventually we will be able to use quantum computers in a much more fluid way, so that it will ideally integrate quite well into the computational package that we normally use. So we don't really, as an end user, think about now we're using a quantum processor unit, but instead we're just trying to solve a problem the best way we can, and then we will have a layer of software that is sort of taking the decisions for us depending on what we want to solve and how accurately we want to solve it and in what time frame we want to solve it. In the Novo Nordisk Foundation, we have a focus on developing technologies and fundamental research in both science and engineering that can help us solving tomorrow's problems. So we have an eye for how the basic science community in Denmark and the ecosystem that is relevant for making great basic science can ultimately be turned into applications, great innovation, and leading the Danish industrial sector to have great solutions for tomorrow's problems.